Today we are going to cover systems of inequalities, and you guys have covered most of it in Algebra 2, but this is going to be an extension. Let's go and start with the following. Sketch the following graph. They give you a quadratic equation, and all of you guys have a small graphs. In case you don't have graph paper, you can go ahead and use those instead. So in this case, I'm going to go and create a 5 by 5 graph. And most of you guys can just cut it or just tape it. You might want to just go and do the graph first before you tape it or glue it. And I need to be able to graph the following inequality. Now, we know that this is a quadratic equation. So in order to be able to graph y equal to x squared minus 1, and I'm going to graph the boundary line first. I need to be able to find my vertex. And in this case, I can just use my h and my k, where my h is 0 and my k is negative 1. Otherwise, you can use your negative b over 2a to find your vertex. So in this case, this is 0, negative 1. And to be able to find additional points, I'm going to create a table. And some of you guys have a graphing calculator, so you can just go ahead and enter the function called the table function. Otherwise, I have a 0. I'm going to plug in a 1. If I plug in a 1, will be 1 squared is 1, minus 1 is 0. So 1, 0. And I'm going to reflect it since this is a parabola. I'm going to plug in a 2. That'll be 4 squared minus 1 is 3. So 2 and 3. And I'm going to reflect it. And I plug in a 3. 3 squared is 8 minus 1. 3 squared is 9 minus 1 is 8. And there's no more space. Now, one of the things that you have to remember is that whenever you graph inequalities, whether your boundary line is solid or dash, so we know that if it's less than or greater than, it's going to be dash to indicate that those points that are on the line are not solutions. Less than or greater than, or vice versa, less than or equal to, greater than or equal to is going to be solid. So in this case, this is going to be a solid line. And you want to make a parabola, not a V. I'm going to round it and go through my points. And now, because this is not an equation, it's an inequality, we need to be able to shade either the inside or the outside. And you need to be able to test a point. So I'm going to test any point. And in this case, you can test this point or this point. The easiest point to test is 0, 0. I'm going to test 0, 0. And I do need to be able to see this on your homework. I'm going to test it on this inequality. So therefore, the value of y is 0. The value of x is 0. So it gives me 0 is greater or equal to negative 1. I need to decide if this point is true. So therefore, 0 is greater or equal to negative 1. So that is true. So therefore, this point is a solution. That means that all the points that are inside are also solutions. So we're going to shade all those points. If it happen to be false, that means that all the points that are solution are on the other side of the graph. Now let's go continue to example number 2. Example number 2, we have 3 inequalities that we need to graph. And we need to also label the vertices. So therefore, I'm going to create a 5 by 5 graph, or you can use the ones that you have. And I'm going to graph the first equation. So I'm going to graph the equation x minus y is equal to 2 or less than 2. So therefore, I'm going to leave the y by itself. That gives me negative y is less than negative x plus 2. I'm going to divide by negative 1. And when I divide by a negative number, don't forget that we flip the inequality. That'll be positive x minus 2. So therefore, I'm going to graph this inequality. Negative 2. My slope is positive 1 and up 1. You want to make sure that you make as many points as possible on a 5 by 5. Because we're going to have to find the vertices as well. In this case, this is going to be a dashed line. So your boundary line will be dash. And now I need to be able to decide whether I'm going to shade one side or the other. So therefore, I'm going to test a point. And you can test any point that you want. I prefer to test 0, 0 because it's a lot faster to simplify. So therefore, that will give me 0 is greater than 0 minus 2. So 0 is greater than negative 2. That is true. So that means that this point is a solution. So that means that all the points that are solution are on this side. And I'm going to shade it very nice, very light, because I'm going to have to go back and erase part of it. I'm going to grab the second one. X is greater than negative 2. So x is negative 2 is going to be a vertical line. And also, once again, it's going to be dash. Make sure that you are using your ID or a ruler to make straight lines. And I need to be able to decide which side to shade. And I know some of you guys can guide yourselves by whether it's greater than or less than, but I need to see it more mathematically, and you need to be able to write down test, and need to tell me which point you're going to test. In this case, I'm going to test 0, 0. I do need to be able to see this on your homework. So therefore, that'll be 0 is greater than negative 2. And this is also true. Therefore, 0, 0 is a solution. So therefore, all the solutions are on the right. And I'm going to graph the last equation, or inequality. And y and 3, that'll be a horizontal line. In this case, it's going to be a solid line. And I need to be able to decide which side to shade. So therefore, I'm going to test a point once again. I'm going to test 0, 0. So I'll be 0 is less than or equal to 3. And that's also true. So therefore, I need to shade the lower side. 0, 0 is the solution, so I'm going to shade this side. If you notice, the section that is shaded 3 times is going to be this triangle here. Because this is enclosed, we see that this is bounded. Where example number 1 was unbounded. Let me use a pencil, makes it a little faster. So all those points will be solutions for the system. And I need to go back and erase the ones that are not solutions. So notice that this system is bounded, where the system before was unbounded because it continues further up. Now, I do need to be able to label the vertices. And what's nice about this problem is that we actually can see the vertices and they are on a specific coordinate point. So in this case, let's go and label A, B, C, vertex A, B, and C. So A will be at -2 and 3. B will be at 5 and 4. And C will be at -2 and -4. Let's continue to the next example. Example number 5. Now remember that I did skip a few examples from the textbook just because they're very simple, but you might want to go through and read through them. I'm going to go and create a 5 by 5 graph. And then I'm going to go through the same process. We have 3 inequalities in this system. So therefore, I'm going to graph the first one. Now we're graphing the boundary line. So there are times that when I'm graphing the inequality, I write down as an equation, and you'll see that that's often done. Or you can just leave it as inequality. Either one is fine. I want to leave the y by itself. And once again, I need to be able to find the vertex. So we can remember whether this is the vertex will be 0 and 2, or you can go through a process and find the x value of the vertex by -b over 2a. But whenever it's in this format, h will be 0, k will be 2, so therefore my vertex is 0 and 2. I'm going to go and plot it. And I'm now going to make a table of values. Let me just place it right next. And some of you guys are using a graphing calculator, so you can type it up, go on the table of values. Otherwise, plug in x and y. I'm going to plug in a 1. 1 squared is 1, -2 plus 2 is 0. So 1, 0. And I'm going to reflect it, since that's the vertex. I'm going to plug in a 2. 2 squared is 4, -8 plus 2 is -6. So 2 and -6 still fit in our graph. A little off, but it's fine. Now in this case, this is going to be a solid line. So I want to make sure that I make it curved as a parabola. So curve it and come back down. And I need to decide whether I must shade the inside or the outside. So I do need to be able to test a number, a point. So in this case, I'm going to test 0, 0. You can test any point. Now, if the parabola happens to be going through 0, 0, you might want to test another point, or you have to test another point. So let me graph, this should be greater than or equal to, and I'm applying to the original function or into this one if you are careful with inequality. I'm going to apply into the original function. 2x squared plus 0 is greater or equal to 2. Plugging in 0. Therefore, 0 is greater or equal to 2. That is a true statement. No, that's false, right? That is false. So that means that 0, 0 is not a solution. So that means that all the solutions are on the opposite side. I'm going to shade it very lightly. And now I'm going to graph the other two. So graph the other two, and then we can compare our graphs. Go ahead and pause it. Great. So let me go and graph the second one. X is less than or equal to 2. It's going to be a solid line. In this case, it's going to be a vertical line. And you guys can see that this is your intersection. I'm going to test a point, 0, 0. So it'll be 0 is less than or equal to 2. That one is true. So therefore 0, 0 is the solution, so I must shade all the points towards the left. So now you can see this will be part of the intersection. But we have a third graph. So we're going to graph y is less than or equal to 1, which is a horizontal line going through 1. It's also going to be solid. I'm going to test a point. I'm going to test 0, 0. So therefore it'll be 0 is less than or equal to 1, which is true. So therefore all the solutions will be below. And you'll see they intersect in here, this section here. I'll make it a little darker. And it also intersects in this section. And it's unbounded. This section is unbounded and this one's bounded. And let me go back and erase the other part. And now I need to be able to find the vertices. So in this case, we have one vertex here, one vertex here, one here, and one here. Now some of them are easier to find, such as this one here, which is 2 and 2, 4, 5, 6. That'll be 2 and negative 6 will be your vertex. We'll call that A. Vertex B, it's also easy to find, which is 2 and 1. Vertex C and D are not going through a specific through a whole number. So therefore we're going to find it mathematically. So let's go and find vertex C first. And if you notice, this vertex is made out of this horizontal line and this parabola. So therefore, this horizontal line is this equation here. And I want to use an equal sign now. And this equation here. So therefore, to find the intersection, just like we've done in your previous sections, I'm going to do it by substitution. I'm going to plug in the value of y, so therefore that'll be 2x squared plus y equal to 2. The y value is 1, so 2x squared is equal to 1. X squared is equal to plus or minus 1/2. Take the square root on both sides. So x equal to square root of 1 is 1, square root of 2, and let's not forget your plus or minus. I'm going to rationalize it. So therefore x equal to plus or minus square root of 2 over 2. And we already have the y value. So therefore, your vertices is going to be, both of them will have a 1. One of them will be with a positive square root of 2 over 2. The other one will be with a negative square root of 2 over 2. And we can convert to a decimal, but in this case, we're going to leave it as a square root. So this will be the positive square root of 2 over 2 comma 1. And in this case, we'll also find the d, which is negative square root of 2 over 2 comma 1. Now remember that if it happens to be on the grid, then you don't have to go through the process. But if it doesn't happen to be, you have to go through just like a system of equations that we did on the last unit. Now, let's assume that on the previous example, on example number 4, if you want to prove that those were the correct vertices, we can go through the same process. We can decide that vertex A is made up of those two equations, or two inequalities, and then find the vertex just by substitution, or in this case, just 1 point. Do the same thing with vertex B, and we find the vertex, and do the same thing with vertex C, and find the vertices. But since we already graphed it, we can see it visually where the vertices are located. Example number 9. Remember that you want to go through the other examples in your textbook, but we're just going through the more basic ones, or the more complex, we can say. Now let's go through example number 9. Remember that you want to go through the other examples that are in your textbooks in case you need some help with your homework. I'm not going to go over every single word problem that's there. Some of them are a little simpler than this. So go ahead and read through it and highlight the information that's given to you and give you guys a minute or two. So it says the liquid portion of a diet is to provide at least 300 calories and 36 units of vitamin A and 90 units of vitamin C. So therefore we have three components. A cup of dietary drink X provides 60 calories, 12 units of vitamin A, 10 units of vitamin C. A diet cup of dietary drink Y provides 60 calories, 6 units of vitamin A, and 30 of vitamin C. We need to set up a system of linear inequalities that describes how many cups of drinks each one should be consumed. And now, once we have the system, you don't have to graph it by hand. You can actually just go into any type of graphing utility. Today I'm going to be using decimals to do so. So let's set up an inequalities. We have 2 cups. We have drink X, and they'll be your X values, and drink Y will be our Y values. And we're going to start with the 300 calories total. Drink X provides 60 calories, so therefore there'll be 60X, where drink Y provides 60 calories as well, so plus 60Y, and that'll be 300 calories. We are working with inequalities, so it says that it needs to provide at least 300 calories. So therefore, the number of calories has to be greater or equal to 300. Now let's go and this will be for the calories. Now let's go and set up another inequality for the vitamin A. So that'll be 12 vitamin A in cup X and 6 units of vitamin A in cup Y. And it has to be greater or equal to 90. And the last one will be vitamin C, so it'll be 10X plus 30Y has to be greater or equal to, this one's 90 and that one's 36, correct? Thirty-six is your vitamin A. And this will be your vitamin C. So once you have it done, you can go into decimals, and let me go ahead and type in the first one, which is 60x plus 60y is greater or equal to. So notice when I do greater than or equal to, I can just press the equal sign. It'll change it automatically. That's the first one. The second one will be 12x plus 6y is greater or equal to 36. And the last one will be 10x plus 30y is greater or equal to 90. Your graph will look something like this. Now, we do also need to be able to bound it because your x or y values cannot be less than 0. So we're going to bound it on the left. Y, it has to be greater or equal to 0. And also on the x value, x has to be greater or equal to 0. And now if we need to, we can actually find the vertices. Decimals will allow us just to click through it and find the vertices for each one. And you can go ahead and crop it and include it as part of your homework. And then once you print it, you can just highlight the part that is your solution. So you can choose to just go and you can also copy it over to your paper and then highlight it, or you can just paste it just like I did and include it on your homework. Your homework will be on the left, and you guys have that with you. Have a great day, and I'll see you guys next time.